Innovate, invent, and unleash growth now. Leverage the power of digital to make your organization resilient, responsive, and ready to scale. Set strategy and execute along the 3 dimensions of digital transformation to emerge stronger and lead the future of aerospace and defense. Time to fly beyond.
I'm Graham Warwick, Executive Editor for Technology, and my guest is Dr. Tim Grayson, who's Director of the Strategic Technology Office, STO, within the Defense Advanced Research Projects Agency, DARPA, an acronym most of you will be very familiar with. So DARPA was founded in 1958 after the Sputnik launch, and its charter was to prevent the US ever being taken by surprise again. And not just to prevent technological surprise, but to inflict technological surprise on US adversaries. And it's been, pretty successful over the years. So if you fast forward 60 years from 1958, more than 60 years, you get to today, and the pace of commercial technology development has accelerated so much that it is presenting new challenges and opportunities when it comes to both preventing and inflicting surprise. So Tim, there are several offices within DARPA. Can you sort of tell us what the specific remit of STO is within that organization?
Yeah, certainly. And let me start by thanking you, Graham, and your readership and the AvWeek community here for this opportunity today. So there are 6 technical offices within DARPA, and all of DARPA is what we call mission focused. So we, unlike some of the grant giving types of federal agencies that are more open-ended, everything we do is a research project. That being said, the types of research projects vary in the level of maturity. So some offices work basic sciences, others work more component level researches. STO is one of what we think of as 2 systems level offices. So we focus on things that are more developing direct military capabilities at the system level. Our sister office is TTO, Tactical Technology Office, and we have a rough division of labor where we focus on things that are so-called mission systems, the black boxes, the sensors, the communications, electronic warfare, et cetera, where TTO is heavily focused on platforms and weapons.
So there, if you go onto DARPA website and you see the page there for STO, it talks about how a lot of its focus is on joint multi-domain operations, which is a big issue these days, about trying to break down the barriers between the services, between the air, surface, sea, space domains, and sort of and enable truly joint operations. So can you just kind of start by, giving us, what is DARPA's vision for this joint multi-domain operations, and how would they differ from how we do it today?
Yes, certainly. So I find this time and all the work that's going on in apologies for the acronyms, but I'll just call it JADC2 to make it less of a mouthful. That's how the department's heavily referring to it: Joint All-Domain Command and Control. And it's really what is so exciting to me is if you go back to my predecessor twice before me, Dr. Nils Sandell. He really set STO down the course of what we were calling a system of systems strategy. And this was based upon the realization that in today's modern world, where, as you pointed out, the pace of global technology is driven by the commercial market. And there's so much technology, especially in the software and the computer science area, that's available to anyone in the world. That we've seen it in commercial industry, where it's driven a huge acceleration of technology, and that applies to military technology as well. So really all of the world's major powers have been progressing in incredible speeds compared to certainly the Cold War, even the 20 years intervening. So speed is critical. And the realization behind systems and JADC2 is that we can't necessarily rely on, I'll say, a conventional US dominance strategy where we want to look at a mission, look at the best thing we can do for that singular mission, and problems, and effectively field new capabilities through the combinatorics of things. You know, instead of building the next great platform that has also the best sensor and the best weapon all tied together on that one platform, imagine a battle space where you can address the problem at hand by saying, what is the best sensor in this battle space? It doesn't necessarily have to be on the same platform that has the best weapon in that battle space. So we believe there's a tremendous amount of effective capability that comes through these combinatorics of being able to do these system of systems combinations. There are a lot of other secondary benefits that come from that. If you can start spreading things geographically, spatially distribute things over large areas, that might create a resilience that you don't have if you just have a few singular capital assets. I might be able to mix and match, so there's a greater diversity of things. You know, in the whole engineering world, we talk about how, you know, diversity and redundant pathways create greater reliability. Well, imagine that being raised to a full force structure level, where I can have diversity and multiple redundant pathways through how I would field a capability or generate a force. So all of these things are fundamental benefits of you know, systems of systems thinking that's captured in JADC2. And like I said, five to 10 years ago, when my predecessors started thinking about system of systems, it was a almost mind-blowing concept to the military. You know, how could we ever operate with these distributed capabilities? How could we ever coordinate manage the complexity of the system of systems? So in that intervening time, you know, put a figure rock in the Pentagon these days without someone saying JADC2. So there's been a huge change in mindset and an acceptance by the broader military and operators that we have to learn how to fight this way. So that's the exciting side. The challenging side is that complexity of system of systems has not gone away, and that's where STO is really focused now. And you mentioned in the introductions, and we've talked before about our big theme of mosaic warfare. And you could, in short, you can think of mosaic warfare as being JADC2 on the fly. Instead of saying these system of systems architectures have to come together in one very rigid, highly engineered manner, that would be a jigsaw puzzle metaphor. The mosaic metaphor is, I want to be opportunistic. I mean, you know, what tiles happen to be available to me, then be able to compose, ideally right there at that operational time of need, the specific system of systems architecture for that immediate problem.
So yeah, so when we talked before, you made this point that, you know, because I mean, system of systems and net-centric warfare, system of systems, around as a concept for decades, but as you've said before, the problem was that we approached it in a, you know, we had monolithic platforms, and when we connected them, we created monolithic systems that then become almost impossible to upgrade or to split into smaller parts, you know, and use just a piece of the system of systems to do a particular job. So what you're trying to do with mosaic warfare is really enable, as you say, the pieces to be assembled on the fly in any combination that you want. I mean,
yep, that's exactly right, Graham. And to use this analogy, imagine in your daily life how simple it has become to you know, go out and get a new peripheral for your computer and plug in a USB cable, or to download a new app to your tablet. You know, for those of us with some gray hair or no hair, you'll remember, you know, say back in the 1990s time frame, how complex it was to install that new printer. You know, where you had to go make sure you had the right disk with the right driver, and you needed a certain amount of technical skill to put together, you know, the computer sitting on your desktop, you know, which you could think of as a system of systems. And now in our daily lives, it's an afterthought. We want to make it that same way for the warfighter. So where a lot of the current department's JADC2 thinking is right now. And again, I don't want to berate it at all because I find it incredibly exciting. But it's still very much in that requirements stage and concepts development stage. And it's very heavily tied to acquisition concepts. There's a very significant danger, as you pointed out, that if we view a system of systems architecture as a thing that has to go then through an acquisition or some kind of program office or joint program office done in an acquisition timeline, there's going to be a certain brittleness that gets baked into that singular architecture. There's a huge complexity that comes with that architecture. And oh, by the way, one of the big challenges with our requirements process is no one has that crystal ball that can precisely predict the future. So either that architecture isn't going to be quite right when it's actually needed, or similar to the way we build platforms today, that architecture is going to have to be over-provisioned to try to accommodate all the uncertainties that a future fight might bring us that we just can't predict precisely. Now imagine in that, plugging in a USB cable scenario, imagine a bunch of warfighters, sitting there during the workup to a campaign, or even sitting in the ready room, doing their mission plans for the next day's sorties. They don't think of themselves as technologists, and they certainly don't think of themselves as a program office. They have a mission to address. So we want to start, what we've been doing is decomposing that problem and starting to say, what technologies would they need? Where they don't have to view themselves as technologists, no different than you don't have to view yourself as a technologist to download an app to your tablet. But that nevertheless, they could be doing highly technical things and using very sophisticated tools where they're tailoring a system of systems force package to that very next day's mission. So it's really taking the exact same concepts that everyone around the department is thinking about with JADC2, but translating it from being this multi-year, maybe even decadal, planning and engineering and acquisition problem to something that could be a 24-hour time cycle mission planning problem where the technology sort of vanishes behind the scenes.
So so from an SDO viewpoint, what do you have to go after to enable that? What are the technologies or the capabilities or however you describe them, solutions that you have to go after to enable that change?
Yeah, certainly. So we have sort of bent our technologies to implement this into what we think of as 3 pillars, and the first of those is planning. Sounds simple, but if for anyone who's ever been involved in doing any kind of planning for a major organizational or institutional kind of action, and this can be people organization, force structure, org chart in a business. Right. There's a tremendous amount of planning and structure that goes into that. So we're building a series of tools that for example, we've got a program, two programs in that pillar that I think are illustrative. One of them is called Proteus, and I apologize, I don't actually have all. It is an acronym. We can get you that acronym list later.
So, but DARPA's famous for the way it does its acronyms. So.
That's right. So Proteus is looking at this problem of, for example, with the U.S. Marine Corps. The Marine Corps is known, really you could think of as a very mosaic force already. But at the same, in the sense they have, things like combined arms maneuver, and the notion of MUs, Marine Expeditionary Units that can be composed to a particular mission at hand, ranging from humanitarian relief to a major war. The challenge with that is the fundamental building blocks they have to work with are still rather large and coarse-grained. Think a company-sized unit level, and that's not a problem if you're going to deploy with something the size of a MU. But now imagine you're doing something where I'm force limited. I've got a limited footprint. There's also an efficiency that comes with our mosaic ideas, and Proteus is pushing that by saying, effectively, how could I design a hybrid company that allows me to draw from all the diverged capabilities that I might normally put into a Mu, but put it into the footprint of a company. So it's helping us do the complex planning of that economy of force. So there's an efficiency that comes through it, as well as an effectiveness. That Proteus program also highlights another aspect of how we build our portfolio, where we don't want to fall prey to our own office becoming a rigid system of systems jigsaw puzzle. So there's a joke that the #1 rule of DARPA is never depend upon another DARPA program. So we're not requiring these programs to all plug in together very tightly and precisely. Every program has standalone value. So Proteus is already going down that path of enabling partners like the Marine Corps to use it as an experimentation tool. So they can start using prototypes today to do anything from theoretical, more academic, force structure experimentation, to, if they wanted to, possibly use it for future force planning. We envision it in the future as being a tool that they could actually deploy operationally and do this 24-hour reconstitution that I described. Another interesting thing that Proteus highlights is that on the surface, some of what we're producing within STO and Mosaic warfare screams of what some people call weird software stuff. It doesn't look DARPA-ish on the surface. But no different than how simple it is for a consumer to download an app. We like it that way. We don't want it to look complicated and techy. So that's an example of how Proteus enables that planning pillar. Where a lot of the meatier, what you might think of as more hardcore DARPA technology rolls in, is in what we call interoperability. So under the hood, so to speak, of these Mosaic architectures, there's a lot of machine-to-machine connectivity that we don't have today. And when the department has attempted to do this in the past, it usually has involved of pushing towards some universal standard. If only all of our weapon systems can be built to this standard, everything will be great and it'll all be plug and play. And the challenge with that is, one, developing those standards is insanely hard and usually involves a lot of compromise in the performance of those standards. Secondly, tell me when the moment in time is going to occur that I call the Big Bang moment, when everything can in one giant step move over to the new standard. We're always going to have backward compatibility. We're always going to have forward compatibility. In some of our previous discussions, I've talked about our SOSITE program that is working this problem of dynamic interoperability, I'll call it, plug and play type interoperability, up at the message or the application level. Now imagine you have two sensors that you want to talk to each other that, say for a data fusion problem, and they're built on entirely different standards in terms of how they present imagery or how they present a tracking message or something of that nature. SOSITE will automatically develop the software to translate between those standards, irrespective of what original standard they were built toward. The other thing we've really been pushing on is lower down in the stack. It doesn't do any good to have something like SOSITE that translate these messages if the messages can't be platforms. So we have to have communication networks that can actually interoperate down all the way at that radio level. Right. So the military has been working gateways for a long time. But again, those gateways are jigsaw puzzles. You've got to have one big radio node that translates between the different radios. And that's all hand configured. It doesn't have any sense of routing, let alone something that has an internet feel to it. So we've got a program called Dynamo right now that's reaching maturity. That it's not creating a new gateway. It's relying on someone else having that box, so to speak, that still has all the different radios plugged together. But what it does is adds a layer of software in between all those radios and a user that turns that gateway into more of an internet-like experience, allow you to create a virtual network layered over the top of a very heterogeneous mix of tactical radios. And then our third pillar is what we call execute. It's one thing to build all these new complex force structures and have all these machine-to-machine architectures. Human is a piece of that force structure. And as a lot of your readers may be very painfully aware, introducing a new system to military operators requires significant training, not just to how to use the system, but also the tactics that go around using that new system. In this vision of, say, 24-hour force structure modification or introduction of new capabilities, imagine you're the poor soldier or pilot sitting there in the ready room saying, here's a bunch of new equipment and here's a bunch of new tactics developed by an AI algorithm, go fight, without a day in a schoolhouse, let alone exercising on a training range. So we've got a series of programs in that execute column that are trying to simplify that operational problem. First of all, at a very high level in the hierarchy, by doing things like our ACK program, the Adaptive Cross-Domain Kill Webs that we talked about in the past. It is trying to help command level deciders, although possibly lower level deciders if doctrine permits, do real-time reallocation of resources, maybe even across services, very, very joint in that JADC2 concept. At the other extreme, we're looking at how do you automate what I've heard military leaders call the training of fingers, or the button pushing, technical skills that go along with the new weapon system. How do we automate those lower level functions away so that learning how to use a new weapon system is much more, I'll say, video game, and that allows the warfighter to focus on the tactics and the more cognitive skills that he or she has to learn. And our ACE program, the Air Combat Evolution activity, is creating a demonstration of that by automating dogfighting with AI. While a pilot could sit there and do battle management types of things. So that gives us, it gives you sort of certainly not our entire portfolio, but it gives you a little bit of an example of what goes on in each of those pillars.
Oh, right. I mean, it is interesting because you can see when you lay it out like that really, to make this work, you have to go from the top level to the bottom level. You have to have the connectivity layer. You have to have that ability to communicate, or you can't do any of the jointness. But at the same time, if you have jointness but no ability to plan to use that jointness, it's of no use to you at all. I mean, you have to have all of the pieces to sort of enable it. So, I mean, how far along are you towards this vision? I mean, how much progress have you made, and what's the sort of the reaction from the establishment to what you're trying to do? Are you seeing that? You talked about JADC. There is this multi-domain thinking, but as you say, it's not an on-the-fly type of approach they're thinking of. What sort of what progress are you making? What sort of traction do you think you're getting with the concept?
Yeah, so I think we're making a lot of progress. There's quite a few of the programs that I mentioned already are already reaching a stage of maturity. So for example, both Proteus and Dynamo that I mentioned are heading into their third and final phases that'll be getting to some, larger scale types of experimentation with real communications or weapon systems and operators. So some of these piecewise programs are reaching, toward at least a DARPA level of maturity. A couple interesting things are happening as we look at transition. First of all, as I mentioned before, we've built this whole portfolio in a federated manner. So in a more traditional DARPA fashion, we are looking at transition of these individual programs in a 1v1 piecewise type manner. So to take Proteus as an example, we're in discussions, with the Marines and some of the other services, or even the combatant commands of, hey, could you use this tool just for your own experimentation or your own training? And we're getting good traction in them picking that up. In Dynamo, I don't want to say specific program names because we haven't coordinated with our partners for this interview. We are working right now with a very specific military gateway program, a radio gateway program, and there's a clean pathway right now to transition Dynamo as that networking software that would sit on top of that gateway. So we're getting a lot of good traction on that traditional, 1v1 transition of our programs as they mature. But on the other hand, there's still a lot we think we have to do, and I'll mention the comms as an example. So we still are building our portfolio out and filling in what we've considered sort of the still big gaping technical holes. As an example, and this is not a program yet, it's likely to be a number of new programs. But we're considering the notion of how do we make that Dynamo-like networking even more plug and play. How can we be more opportunistic? So instead of relying on a dedicated gateway that we're layering on top of, I call it a tapioca pudding model. How could there be this goo of lots of different types of networks in the environment? And then the tapioca chunks are maybe special purpose nodes that are perhaps the only, government-owned node, or maybe in the pudding portion, there's a mixture of commercially available networks aside very legacy tactical radios. But the tapioca chunks might be completely new. I hate calling them gateways, but like radio relay nodes that perform some of that gateway function and host the software, but in a much more flexible, discoverable kind of manner than we have in our current Dynamo model. So we still have lots of additional technology that we need. Now, I'll say in terms of broader transition though, and our marrying up to the broader department JADC2 efforts, there are a lot of exciting things happening and still a few challenges that remain. First of all, back to my mantra, we are building a federated portfolio. We're not developing a turnkey thing called mosaic warfare. At some point in time, there are going to be a lot of loose ends, because we're not working that comprehensive capability. In true DARPA fashion, these individual standalone programs are creating examples of what some of these mosaic functions are going to be. But someone in the services is going to need to pick that up and say, now I need to make this planning tool tailored to my capabilities and my particular operational needs. Still some significant technical work, but not DARPA hard, so to speak. We won't necessarily check all of those blocks. So we're still out there looking for those types of partners. At a higher level, a lot of what we're doing, rather than being transitioned in a traditional manner to some program office that'll turn it into a program of record, a number of our programs are stimulating new thinking of actual organizational structure and what I'll call institutional reform. And again, I think all the work going on in JADC2 is a tremendously exciting opportunity in that regard. One of the ways that we've described our ultimate, long-term vision for Mosaic is in 3 waves. The first wave really is what's happening across the department in JADC2. It's the services and the combatant commands and the joint partners doing experiments in system of systems architectures and actually trying to implement some of these things. And that's a very critical first step, because it's creating the groundwork that the military is thinking that way, and a lot of the key elements are being put in place. As that evolves, we're hoping to get enough traction on our much more dynamic, much more composable mosaic technologies. That this second wave arises. This notion that instead of there being, a JADC2 JPO or cross-functional team, that's building a new architecture in acquisition time, that we've delivered all these tools to something much closer to the operational edge. And in the spirit of institutional reform, we actually have a vision that there's, some type of new actual force element that lives out at that tactical edge. Think of it as a combat support element. We've used terms like a mission integration operation unit. I also call it figuratively the geek squad for the DoD. So imagine these as being, a unit that is there for what we would think of as traditional technical support. Just like we have people that do IT support or flight line logistics support. Bolting pods on aircraft right now is something that's already that combat support function. Imagine that at a slightly more technical level. Someone who can operate tools like stitches, someone who could, be the ones to configure all of these dynamo-like network of networks types of things. So it's not DARPA's job to say specifically what these combat support elements look like, but we are actually pursuing a series of low-level studies to say, if we were wildly successful and we have this whole portfolio of new tools, what would these combat support elements actually look like and need to be and need to do? And we've got a few small funded efforts taking a look at that, and are working with partners in the JADC2 enterprise of where would it fit in what they're doing and how would they actually implement this. And then finally, there's a very distant third wave, and I say it's distant. I won't be willing to go out on a limb and say what the actual absolute timelines are, but we've got to do those first two waves. We've got to prove that there's warfighting value in these JADC2 architectures, and then we have to prove that with the systems, more or less, that we have today, that we can do this mosaic combat support compose at the edge. If we actually build confidence that all of this is real and workable, it will change how we think about buying future weapon systems. Because now in all the visions that are out there of, buying small platforms and swarms and, things that the individual piece parts, the tiles, if you like, are smaller and less proficient by themselves, but in aggregate give us a huge capability. We will enable that future and change how the department acquires and builds its broader, force ensemble. Yeah, I don't, while parts of DARPA are looking at setting the table for options there, from a mosaic standpoint, that's our distant third wave.
Cool. Well, I mean, that really, to me, that you start to see the threads coming together there, because one of the ways of dealing with commercial technology is to iterate your platforms or your systems, iterate them more quickly. Traditional procurement doesn't allow you to do that, because you have to have a big program with a long time period, because that's how we afford things, that's how we do things. A lot of people are talking about this, let's just do a small number of a single mission airplane or a small number of this, and then quickly move to the next generation. This sounds like, if this can be worked, those little pieces, if you do 100 airplanes of this particular capability or this particular type, you can plug it into a mosaic in a way you can't with a more traditional approach. So you can see how this starts to enable this vision of just the whole enterprise moving more quickly as technology evolves. So I think we have
absolutely, Graham. Yeah, to pull the thread on that, maybe is I know we're late on time, so a parting thought perhaps, in terms of where I see the real importance of this mosaic mindset. That commercial analogy you laid out is the thing that the software and IT market space saw emerging in the late 90s with the dot-com boom, and we see it in spades today. People started talking about time to market. In 1999, there were major global 100 corporations that seemed absolutely unassailable, because of the capital barriers that they had and the brands that they had. And they very quickly discovered that upstarts that could move fast and outmaneuver decimated those monoliths. And now today, when I talk to a lot of our commercial counterparts out there, they focus much, much less on what their product offerings are than they do on their infrastructure and their workflow. And it's all about speed. If the first product they put out there doesn't have a great customer acceptance, hey, 24 hours later, we'll have a different product for you. And we'll keep iterating until we win. That's going to be what happens in our future military, I will predict. And time to market is going to be everything. So if we rely on being the large, capital barrier, we saw in the commercial world where that led. So I think our challenge ahead of us is we have to be able to think like the agile upstarts and the dot-coms, and how do we win that time to market battle?
Great, Tim. Well, thank you very much for walking us through this. My experience of DARPA is that sometimes things appear and disappear in DARPA, but they always reappear at some place in the future, and they always influence and change the way we think about things. I mean, nothing's ever quite the same again after DARPA has touched something. So I think that, you know, don't know how long it's going to be, but you're going to change the way people think about this thing. So great, Tim. Great to talk to you, and thank you very much. So, folks, that's the end of the Tech Talk, and we'll see you on the next one.